In lesson 30, we're going to look at two more triangle congruence theorems: angle side angle, also known as ASA, and angle angle side, AAS. So in example 1, these are exactly how they sound, just like side 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 and side angle side. These triangle congruence theorems are shortcuts to show that triangles are congruent. And we know, once we know the triangles are congruent by these theorems, we can use CPCTC and know that corresponding parts of congruent triangles are congruent. So in example 1, it says, use ASA congruence to determine the measures of sides D, E, and F. It wants us to determine the measures. Well, if we look at this, we already know that this one has the tick mark that corresponds to this. So therefore EF, side EF, equals 6 because of the tick marks. But how do we know that FD and ED are congruent to, how can we find those sides? Well, because of angle side angle, right here we see that this angle is congruent to this angle. They both have 1. This one has the same side, and then, or an included side between the two angles. I'm going to put angle 2. Because of angle side angle for both of them, we can know that corresponding parts of congruent triangles are congruent. So therefore, let's see, the one with line, therefore these sides are congruent. Now make sure you know that FD is congruent to BC. The reason I knew that these two sides are congruent because of this 2 angle mark. And so we were able to figure out which sides correspond. So now we know that FD equals 17 and ED, side ED equals 18. But that's all because of angle side angle congruence theorem. Let's look at the other one, angle angle side. Well, angle angle side would be 2 angles in a row followed by a side that is congruent. So in example 3, it says DE is congruent to LK. Here's DE, here's LK. We know that those are congruent. And it wants us to find the area in the triangles. And I did forget to write this down. It actually does show that in the problem. I just forgot to write that early on. But because of angle, angle, side in both of them, since they have angle, angle, side, the triangles are therefore congruent because of CPCTC. Since the triangles are congruent, we know that the sides that correspond are the same. So I can call this side over here 6. It's between the right angle and the angle tick mark. And then FE and KM are also the same. So I can say 4x minus 2 equals 3x plus 1. And then I solve. Subtract 3x and add 2. So 3 equals x. Therefore, x equals 3. What it wants to know is the area. So we got to plug that back in. I'm going to plug it in here. 3 times 3 plus 1. So your base is 10. And your height is 6. And so now, since we know the base and height, we can use our triangle area formula of 1/2 base times height. Plug it in, substitute your values. 1/2 times 10 times 6. 10 times 6 is 60. 60 divided by 2 is 30. And then whatever your measure would be, something squared, call meters squared. All right, so there would be your area. Now let's actually want to look at one proof. We haven't done a proof using the triangle area congruence theorems yet. So let's look at one of those. It says in example 4 that our given is BD bisects angle ADC, and angle A and angle C are congruent. That's what's given. A and C are congruent, and BD is a bisector. All right, that's a key word that we'll need to use later. And it wants us to prove that triangle ADB and triangle CBD are congruent. So I'm going to do our 2-column style. And I'm going to go ahead and write down statement number 1 is BD bisects angle ADC. And angle A is congruent to angle C, and that's our given. So now from there, how can we go about proving the triangles are congruent? Well, when we're proving triangles are congruent, we usually want to use one of our triangle congruence theorems. We have SSS so far. We have side, angle, side. We just learned angle, side, angle, and angle, angle, side. So those are our 4 congruence theorems that we have so far. If we can get to those, we can show the triangles are congruent. So right now we have angle A and C, and those are check marks. So we have an angle. So I'm going to recommend that we use one of these 3, probably not side, side, side. Now let's look at the other key information that it gives us. It gives us that BD bisects angle ADC. Excuse me. BD bisects ADC. Well, what does that tell us? Well, when you have an angle bisector, that cuts these into congruent angles. All right. So we can say that angle ADB, let's say angle ADB, so I'm referring to this angle, we can say that's congruent to angle CDB, that angle. So we're saying angle CDB is congruent to ADB because of the definition of an angle bisector. Remember, when they bisect, they cut in half. And so now we know that 2 side angles are congruent. We know here's one angle 1, or call that angle 1, angle 2 on both sides. Now, what else do we know? We got 2 angles that are congruent in a row. Do we know that these sides are congruent? Not really, not necessarily. So we don't know that angle side will work. We know that we're going to use something with 2 angles. Let's look at this one, angle, angle, side. Well, if something's a bisector, or well, if you just look at the triangles, notice that if I redrew these like so, we already know these angles are congruent. Well, these are actually the same measure because it's the same side, BD. So therefore I can say BD is congruent to BD. And that is our reflexive property of congruence, when they're equal to themselves. And so since they are congruent, we now have an angle, angle, side congruency. So we can say in our proof, angle ABD is congruent to, triangle CBD because of angle, angle, side. And that's an example of how you would do some of those triangle proofs. You're going to start to see those in your homework. But that's an example, and hope that helps you out.